Observational drawing is a way of translating the three-dimensional world of objects and spaces that surround us into two-dimensional visual representations. Sight measuring is a simple, empirical method for creating drawings from observation, and the only tool you need is your pencil. The basic premise of sight measuring is to estimate height and width relationships of three-dimensional objects and then record these measurements in your drawing. Let's start with a simple example of a three-dimensional sphere. First, I'll take a measurement of its height. Using my pencil as a measuring tool, I'll hold it in front of me, aligning the sharpened tip of my pencil with the top edge of the object I'm trying to measure. I'll then align the edge of my thumbnail with the bottom edge of the object. You can move your thumb up or down the pencil until it aligns. This height measurement is your unit of 1. Holding the measurement in place, turn your wrist 90 degrees so you can compare it to the width of the object. Since a perfect sphere should have the same height as width, the ratio of height to width is 1 to 1. If an object is wider than it is tall, or taller than it is wide, the ratio will change to reflect this. Even though the ratio you determine is an estimate, still double-check your measurements as if you were testing your solution to a math problem. If you're already trying this at home, you may be seeing double. This is because binocular vision only allows us to focus on a single depth of field at once. If you close one eye, it will compress the space in front of you, allowing you to observe both your measuring tool and your subject at the same time. You can even place a hand over one eye if it's easier. Once you have your height-width ratio, you can make a light notation of where you want to place the drawing on your paper. Using the ratio, you can scale the object as large or small as you need on the page. Posture is also important to accurate sight measuring. If you change the distance between your hand and eyes, even slightly, it will change your measurement. So, keep your arm fully extended when sight measuring to make sure that your position in space remains constant. To the same effect, if you change your eye's position in space during the drawing process, this will also skew your measurement. So, try to stay in the same position throughout your drawing. And ideally, keep your drawing surface in a vertical position so that it doesn't require you to turn your head away from the still life. If you don't have an easel like I do in this setup, a drawing board or your paper pad leaned against the back of a chair is a good at-home solution. Once you have your first object in place, you can use it to map out other objects in space. The small sphere is about 3/4 the height of the large sphere, and the two spheres are sitting about half a large sphere width away from each other. Again, it's like solving a math equation. Once you have a single constant of height or width, you can use it to figure out all the remaining height and width relationships within your drawing. The more you practice comparing these height-width ratios, it will become an instinctual way of observing the world. Now let's use the basics of sight measuring to draw a more complex object like a box. I'll start with the height and width measurements as before, from the topmost point of the object to the bottommost point, and from left to right edge. This box is about 1 height to 1 1/3 widths. I'll lightly record this ratio on my page as before. Since I know that the left and right vertical edges are already determined, I'll draw them in now too. To find the inner vertical edge of the box, I can compare its position to the full width of the box. I see the width from the leftmost edge to the center edge as slightly more than 1/4 of the total width of the box. To figure out the rest of the box's form from here, I'll need to determine some angle measurements. To find an angle, imagine your pencil as the arm of a clock. Turning your wrist, you can make the edge of the pencil travel 360 degrees on that imaginary clock face. At some point in that rotation, the edge of your pencil will appear to sit on the edge of the object you're trying to record. You could even attribute a time of day to the angle you observe. The angle measurement will skew if your pencil tips at all toward or away from your face. So, continuing with the clock metaphor, try to not tip the clock's arm off of its rotational axis. If you do, imagine that it will break the glass of the clock's face. Now, by carefully moving your measured angle to the paper, you can directly record the angle you observe to your drawing. If your wrist changes position before you get there, the angle will be off. Like the height and width measurements, it's always good to double check your angles once you've recorded them. Lastly, I'll find the remaining angles and record them in the drawing. Don't be afraid to draw extra search lines. If you draw them light enough, you can always erase them in the end.